Past studies have shown consistent results indicating the ability in neurotypical infants to discern sound and movement in their surroundings. DeCasper and Pfeiffer discovered that less than 3 days old neurotypical infants prefer their mother's voice over a stranger's voice, which demonstrates the infant's ability to recognize their mother's voice. Not only did they find that neurotypical infants prefer their mother's voice, but they discovered that these infants worked for the reward of hearing their mother's voice via the frequency of sucking a pacifier while listening to the voices. Similarly, Simeon, Rigelin, and Balfe discovered the ability of neurotypical infants in discerning biological and non-biological motion, and further, their preference for upright displays in contrast to upside-down displays. As mentioned, both these studies show the results in neurotypical infants. Gitter, Renberg, and Boite discovered that a reduction of orientation to audio-visual synchrony in infancy is a predictive factor of diagnosing autism in 3-year-old infants. This shows that infants with autism, which implies non-neurotypical development, do not develop the same abilities that infants with neurotypical development do when it comes to discerning sounds and movement in their surroundings. Their study compared 3 participant groups: infants who were at high risk of receiving an autism diagnosis but were not diagnosed, named the high-risk group without autism; infants with an autism diagnosis, named the high-risk group with autism; and a control group with infants who did not fulfill criteria for an autism diagnosis, named the low-risk control group. They found that the control group fared best in orienting to audiovisual synchrony expressed in point light displays of biological motion, but additionally found that the high-risk group without autism still fared a lot better in orienting to audiovisual synchrony compared to the high-risk group with autism. This study therefore shows that infants with atypical neurodevelopment, such as infants with autism, are quantifiably less inclined to efficiently process multisensory information. Similarly, a study conducted by Demetrio, Campbell, and Milne compared neurotypical children and children with autism spectrum disorder in preference to point light displays depicting biological motion. Humans are typically highly sensitive to the movements of others. Even the human point light displays, which are point lights moving on a screen as if attached to the joints of a moving person, can provide enough information for us to identify an agent's action, gender, state of emotion, and identity. Visual sensitivity to biological motion can be seen in early human development, such as in 2-day-old infants. We know that even when stimulus information is significantly reduced, recognition still persists. However, we know that children with autism show atypical behaviors due to atypical neurodevelopment. In this study, they found that children with autism did not preferentially care for a point light display of a spinning top rather than a human walker. Neurotypical children, on the other hand, preferentially cared for the human, biological motion in both conditions. Their study shows again a lack in attending to biological motion in children with autism. In another study conducted by Wright, Dubois, and Kelly examined whether children with high functioning autism spectrum disorder preferentially attend to point light displays of biological compared to mechanical motion. Their participants included a high-functioning ASD group which consisted of 18 children, 15 males, with a diagnosis on the autism spectrum, and a TD control group which consisted of 18 children, 15 males. Their results were consistent with these other studies, showing a failed attempt by children with autism to preferentially attend to biological motion stimuli, and showing a non-preference for animate stimuli. I'm curious in finding how infants with atypical neurodevelopment such as infants with autism, will process vocal expressions compared to neurotypical infants. My participants, therefore, will be a group of infants with an autism diagnosis and a control group of infants with neurotypical development. Neurotypical infants will be infants that do not have family members diagnosed with autism. There will be 30 infants per group, and I hypothesize that infants with autism diagnosis will have a deficit in the ability to properly process vocal expressions. With vocal expressions, I'll examine two simple expressions, one expressing happiness via laughter, and one expressing sadness via crying. According to Grossman, within the first year of life, infants begin to reliably discriminate between a variety of positive and negative emotional facial expressions, such as happy, sad, angry, and fearful expressions. Again, according to Grossman's study, happy voices evoked greater brain responses in the inferior frontal cortex. From these previous studies mentioned, we understand that children with autism have a lower neural activity as a result of atypical neural development, which is why I can make the hypothesis that neurotypical infants and children this is why I can make the hypothesis that neurotypical infants and children will prefer hearing laughter, which expresses happiness, over crying, which expresses sadness, whereas children with autism will not have a preference. I will create a reward system similar to the De Casper study, where an increase of frequency in sucking a pacifier will allow the infant to hear and see another infant laughing. I can therefore hypothesize that children with neurotypical development will show an increase in the frequency of sucking the pacifier, in contrast to children with autism who will most likely show a scattered response, which will show their lack of preference to happy vocal expressions versus sad vocal expressions. The results of this study will benefit kindergarten teachers and school teachers, as they will be able to understand why an infant or child with autism may not have a typical reaction to another child, despite the other child showing vocal expressions that indicate sadness or anger. These results will help educators sympathize and understand that simply telling infants or children with autism to look for visual or auditory cues of unhappiness will not help, as children with autism are higher at risk of not being able to process such cues. Thank you for listening.